So today we're starting 1-3, and our objectives for 1-3, we're going to solve linear equations with variables on both sides. We're also going to look at some equations that have one solution, infinitely many solutions, or no solution. So this is 1-3, solving equations with a variable on both sides. So you treat this basically the exact same way you would a normal equation. However, once you've distributed and combined like terms and all that good stuff, your goal is to get x on one side, everything else on the other. Okay, so get all your x's on one side, everything else on the other. So let's look at this problem first. 3x minus 10 plus 4x equals negative 2 times quantity x minus 4 plus 9. Immediately, I'm going to look at the left-hand side. I see this 3x and the 4x. Let's go ahead and combine those. 3x plus 4x gives me 7x. Okay, and if I look at the other side, oh, I can distribute. So I'm going to go ahead and distribute here. I get negative 2x, and then remember, negative times a negative makes a positive 8 plus 9. Okay, is there anything I can do here on the left side? Nope. So I'm going to just copy that down again. What about the right side? Okay, you should be saying, oh, I've got like terms. So I have negative 2x plus 17. Okay, now let's get the x's together. Now when you have x's on both sides, I personally always look for the smaller of the two and decide to move that. Okay, because I don't know about you, but I would prefer to work with positive numbers as much as possible. So I've got minus 2x, that's smaller, so I'm going to move this guy over here. So instead of minus, I'm going to say plus 2x. Okay, 7x plus 2x gives me this 9x. Okay, same thing, it keeps happening. I want to get all my x's together, everything else on the other side. So I got my x's, so let's move this minus 10. So I need to add 10 to both sides. So 9x equals 27. Last step, divide both sides of my 9, x equals 3. That's all there is to it. Okay, let's do another one. So notice this time we have fractions, no big deal. We still treat them just the same. Let's go ahead and distribute. Okay, so I get 1/2 n. Half of 4 is 2, so minus 2 minus 7 equals negative 2n plus 6. Okay, left-hand side, we can combine these like terms. So I have 1/2 n minus 9 equals negative 2n plus 6. Okay, again, I always look to move the bigger of the two n's. So I have a half, or I have the smaller of them. So half and then negative 2. Negative 2 is smaller, so I'm going to go ahead and add 2n to both sides. Okay, so now I have 2.5 n. I'm just going to write that as 2.5. Okay, I've got all my n's on one side. You got to get everything else on the other. So let's get rid of this minus 9. 2.5n equals 18. Last step is to divide. Okay, handy dandy calculator. 18 divided by 2.5. And you get 7.2. So n equals 7.2. Okay, your turn. Please pause the video and try these two problems. I'm going to move this guy over here just so we have some room to work. Okay, so go ahead and distribute first. Okay, distribute on this side. Okay, negative times a positive is a negative 8. Okay, let's get all our z's on one side. 100 or negative 50. I'm going to move the negative 50. So I have 150z minus 20 equals negative 8. Add the 20 to both sides, because I remember I want to get the z's by themselves. So 150z equals 12. Last step, we're going to divide. 12 divided by 150. 0.08. And that is my answer. Okay, make sure you've again tried the other one as well. Okay, so first thing we should do is distribute. Okay, so remember when you're multiplying fractions, you can multiply straight across, or you can cross cancel. I see the 8 and the 16. 16 divided by 8 is just 2. So this is really 5 times 2, which is 10d. Okay, same thing over here. 24 divided by 8 is 3. So I have 3 times 5 is really 15. Okay, and if I distribute on this side, it's 6d minus 6, and bring down the plus 1. Okay, time to see if we have any like terms. Nothing on the left side here, so I'm just going to copy him down again. I have the negative 6 plus 1. Negative 6 plus 1 is minus 5. Okay, let's move the d's all to one side. So 10d or 6d. 6d is smaller, so I'm going to subtract 6d. 4d plus 15 equals negative 5. Subtract your 15. 4d equals negative 20. And finally, we're going to divide by 4. D equals negative 5. Okay, so let's look at another one. So the value of x and 4x plus 6 equals 2 times the quantity 2x plus 3. You betcha we're going to distribute again. Okay, so I didn't touch the left side, so I'll just copy him back down. 2 times 2x is 4x. 2 times 3 is 6. Do you notice anything? You should. Notice the left side is exactly the same thing as the right side. Okay, when this happens, what do you think? Well, when I get a true statement, okay, it's true for everything, we call that an identity, okay? So what this is saying is it doesn't matter what we plug in. Any number we plug in is going to work, because if the left side is equal to the right side, it's always going to be true. So what we call it is infinitely many solutions. So let me just write it up here. I have a true statement that equals infinitely many solutions. A true statement is infinitely many solutions. Okay, let's try another one. First thing, of course, we're going to distribute. Can't do anything to the left, but we can to the right. Okay, 2 times 3x is 6x. 2 times 4 is 8. Okay, let's get all our x's on one side, so subtract 6x. Negative 5 equals 8. Uh-oh, that's not true at all. So, there's no value of x that makes this equation true, therefore we say it has no solution. So if you have a false statement, that means no solution. Okay, false statement, no solution. Okay, please try if you. Okay, t minus 27, can't do anything there. Oh, I've got a negative. Remember, it's just like a negative 1. So let's distribute that guy. Negative 27 plus t. Okay, are these the same? Well, t minus 27, what happens if I flip-flop this? I have a positive t, I have a negative 27. Oh, both sides are exactly the same. So, infinitely many solutions. Okay, letter B again, pause the video and try these. Okay, first thing we should do is distribute. 16 times 4 is 64. 16 times 3 is 48. Okay, distribute on this side. 96 divided by 2 is 48. So that's a negative because of that right there with the m plus 96. Okay. Let's get all of our m's on the same side. So I'm going to add this 48m over 64. 4, those cancel, equals 96. Ooh, is that right? Absolutely not, so we say no solution. So let's move on to some word problems. Now, the previous lesson we talked about mixture problems. We're again going to look at mixture problems here, but this time we're going to set it up with a chart. Okay, you really want to make sure you understand this chart because that is going to help you a lot. Okay, so we're going to solve this mixture problem. Arabica coffee costs $28 per pound, and Robusta coffee costs $8.75 per pound. How many pounds of Arabica coffee must you mix with 3 pounds of Robusta coffee to make a blend that costs $15.50 per pound? So this is a lot easier when we work with a table. Okay, so let's fill in what we know. Okay, I'm looking at prices, amounts, and total cost. Okay, notice price times the amount equals our total cost. So do I know anything about Arabica coffee? Oh, I know it costs $28 per pound. So I'm going to go ahead and put $28 in my price for Arabica coffee. Okay, still working with Arabica coffee, do we know how much we want? Well, it says how many pounds. I don't know what that is, so let's just call it X. Okay, well, they call it A here. Okay, so I know I have 28 times A, which gives me my total cost. Okay, let's move on to Robusta coffee now. Okay, I know it costs $8.75 per pound. So I can fill this in with $8.75. How many pounds of Robusta coffee do I want? Well, it says 3 pounds. So I plug in 3 there. Again, price times the amount is my total cost. So $8.75 times 3, $26.25. And we got one more round. We got to talk about our blend. Okay, well, I know my cost is $15.50, so I can go ahead and throw that in. Now, how many pounds of coffee did I buy? I had 8 pounds of Arabica and 3 pounds of Robusta, so my total price is A plus 3, okay? Or total amount. Okay, if I have 8 pounds here and 3 pounds here, I have a total of A plus 3. So then again, we just multiply. $15.50 times A plus 3. Okay, so now to come up with our equation, we're going to look at our last column. Okay, my Arabica coffee plus the Robusta equals the mixture. So we know Arabica coffee is 28A. My Robusta coffee was 26.25. And I know my mixture was 15.50 times A plus 3. And from here, that looks like a two-step equation we're really good at solving. So, can't do anything on the left. Let's go ahead and distribute over here. I get 15.5A plus 15.5 times 3 gives me 46.50. Okay, let's get all of our A's on one side. I'm going to move this guy because he's smaller. 28 minus 15.5, 12.5. Okay, time to move this guy over. Okay, I get 12.5A equals 20.25. Okay, and last step, divide by 12.5. I get A equals 20.5 divided by 12.5 gives me 1.64. So A equals 1.64. You know, what was this A? Well, A was our pounds of Arabica coffee. So I need 1.64 pounds of Arabica coffee. And that is my answer. Okay, the chart, super helpful. So please make sure you understand how we get that chart. Okay, your turn. Pause the video and try this. Okay, Arabica coffee costs $28 per pound. Robusta coffee costs $8.75 per pound. How many pounds of Arabica coffee should you mix with 5 pounds of Robusta coffee to make a coffee blend that costs $12 per pound? Okay, so let's start with the Arabica coffee. I know it costs $28, so I can go ahead and put that in. Okay, I don't know how many pounds of Arabica, so we're going to call that A. Okay, remember, price times amount gives me my total cost. So 28 times A is 28A. Okay, let's move on to the Robusta coffee. I know it's $8.75 per pound. And I want to know, I have 5 pounds. So $8.75 times 5. Okay, gives me $43.75. Okay, and then onto our mixture. I know it costs 12. How many pounds do I have? Well, it's 8 pounds of Arabica and 5 pounds of Robusta, so A plus 5 total. And then we just multiply 12 times A plus 5. To set up our equation, remember we look at our last column. I have the Arabica plus the Robusta equals my mixture. And now it's just a matter of solving. Can't do anything here on the left. On the right, I can distribute. I get 12A plus 60. Go ahead and get all your A's together. So I'm going to go ahead and subtract 12A. I get 16A plus 43.75 equals 60. Just a two-step equation now. Subtract the 43.75. I get 16A equals 60 minus 43.75. 1625. Gotta divide by 16. A equals 1.02 pounds of Arabica coffee. And there is my answer. Okay, let's look at another word problem here. Cameron pays 95 cents per song with his current music service. A new music download service charges 89 cents per song with a $12 joining fee. Should he switch to the new service? Well, let's see how many songs would be worthwhile. Okay, so I know the old, I pay 95 cents per song. And I don't know what songs, how many songs I'm going to buy, so I'm going to call that X. The new service is $0.89 per song plus $12. Let's see if it's worth it. Okay, get all my x's together. Let's subtract this 0.89x. Okay, I-95 minus 89 is 0.06x. Okay, equals 12. I'm going to divide. I don't know why I put a negative, my bad. Okay, divide by 0.06. 12 divided by 0.06 equals 200. So it's only worth it if he buys more than 200 songs. Okay, I personally don't buy music, so it would not be worth it in my opinion. I would stick with the 95 cents per song. Okay, but it's really based on how much money or how much songs he would buy. Okay, so Cameron buys 95 cents, or here's a problem for you to try. Please pause the video and try this. Pays 95 cents per song with his current music service. His friend tells him of another service that has a $15 joining fee, but charges 80 cents per song. What number of songs does this new service become a less expensive option than his current? Set it up the same way. 0.95x equals, now we're at 80 cents a song. And let's get all of our x's on the same side. So I get 0.15x equals 15. Divide by 0.15. 15 divided by 0.15 gives me 100. Okay, so if he buys more than 100 songs, it's worth it. Okay, again, in my opinion, I wouldn't pay for it. Okay, so that's how you solve the variable or an equation with a variable on both sides. Homework, please do problems 22, or on page 22, do problems 17 through 41 odd. As always, please make sure you're prepared to ask questions.